Well, howdy, folks, and let us continue with our discussion of naming. Good. So, the consider I want us to start with is consider the monatomic ion formed from the nitrogen atom. What is the formula and its name? Okay, now, last time we were talking a little bit of polyatomic, a little bit about polyatomic ions, but we want to back up and really look at naming from the beginning. Now, when I'm naming things, I really think about two different areas. First, I break it down into naming compounds, and then on the other side, naming ions. Good. And then when I look at ions, we look at two different types. There's the polyatomic, and there is the monatomic. Monatomic. And last time we talked about the polyatomic, and we said, hey, this is an ion formed from more than one atom, and that we really just have to memorize the names and formulas. Now, there are some tricks, right? Or some tips. Ate and ite, right? Ate means one more oxygen than ite. We have per and hypo. Per means one more oxygen than ate, and hypo means one less oxygen than ite. And we know if anything has an ate or an ite in it, that means it contains oxygen, right? What else? That's really about it. And we just said, hey, we just gotta, oh, we also learned about adding hydrogen. If it says hydrogen in the name, what does that mean? That means we are adding a proton, an H plus, meaning I add an H to the formula and my charge becomes more positive by each H that I add. So that's kind of an overview of what we talked about last time with polyatomics. Now, today we want to spend some time on monatomic. Ions, mono means what? This is an ion composed of, mono means one, so we have composed of one atom. Good. And there are two types of monatomic monatomic ions. We have anions, of course, and we have what? Cations. Good. And cation is a metal which loses electrons, and an anion is a non-metal which gains electrons. Good. Now, back to our question. I have a monatomic ion nitrogen. Okay, nitrogen. And it's going to become an ion. So we look at nitrogen. Nitrogen is where on my periodic table? Here's nitrogen. It is what? That would be a non-metal. So that would mean what? Okay, that means nitrogen is going to gain electrons. Now, how many does it want to gain? Well, it wants to end up with a noble gas configuration, so it's going to want to go from 7 electrons to 10. So how many electrons will it gain? Well, 1, 2, 3. So nitrogen and phosphorus are going to want to gain usually 3 electrons. If it gains 3 electrons, then what will its charge be? It will be a -3. Think about oxygen. Oxygen, sulfur, and selenium here. How many electrons do they want to gain? Well, they want to gain 1, 2. So everything here is going to be, when it's in its stable, most stable ionic configuration, it'll be -2. And these guys here are going to be -1s. Okay? So nitrogen, phosphorus, -3s. Oxygen, sulfur, selenium, -2s. Fluorine, chlorine, bromine, iodine, what do we call these guys? They're called the halogens, -1s. Okay, so that's how we determine the charge. My nitrogen group is going to be a -3, 3 minus. My oxygen group is going to be a 2 minus, and my halogens are going to be 1 minus. So that's how I figure out their formula. So that's the formula. That's how we determine the formula. Good. Now, the second thing is naming. So how do I name anions? It's very simple. We take a stem and we add the word ide. Okay, now, what are some common stems? For nitrogen, it's nit. For phosphorus, it's phos, phi, or phos. And let's see. So this would be nitride, phosphide, oxide. What else? Bromide. And those are probably, oh, sulfur is not sulfuride, it's sulfide. And so my stems, these are very common stems. Phosphate, ox, brom, sulf, and sometimes you even get a carbide, which would be a -4, carb, not carbonide, but carbide. All right. Oh, and hydride, hydride. So hide for hydrogen. So those are my typical stems. And really, remember, how do we say what's the name of the ion? Stem plus ide. So formula for nitrogen. Nitrogen, 3-. What's the name? Nitride. All right, here you go. Bring me back when you have the answer. Okay, monatomic ion, bromine. I look at my periodic table. Bromine is right here. It's a nonmetal. It's in my halogen, so it's going to form a -1. Br-. If it's an anion, that means it's going to take a stem plus the suffix ide. The stem for that would be bromide. So what do I say? Hey, this is called bromide. Perfecto. Going further. Haha, caught myself. The monatomic ion formed from magnesium. Okay, and we want to know the formula and the name. We go to the periodic table. Where's magnesium? Blah, 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 blah. Magnesium. Where is magnesium? It's in group 2. What do we call that? We call that an alkaline earth. What? Metal. It's a metal. So that means it's going to form a cation, meaning it wants to lose electrons to gain a noble gas configuration, electron configuration. Here is magnesium. It wants to end up with a neon configuration. So how do I go from 12 to 10? I have to lose 2 electrons, and when I lose 2 electrons, that means things become positive. So this group will have a +2 charge when they form stable ions. My group 1 will have a +1 charge when they form a stable ion. Aluminum here is going to want to do what? It has 13 electron, wants to get to 10. Aluminum is going to form a +3. And my D and F block, we're going to hold for a second because I got something special for you there. Here we go. Magnesium. Oh, yoink. Let's go back, take some notes. Magnesium. What do we do? Metals lose electrons. And so group 1s form +1. Group 2s form +2s, or 2 pluses, sorry, 1 plus, 2 plus. Aluminum forms 3+. And so that's the formula. That's our formula side of things. Now, how do I name it? So in naming cations, it's very simple. Cation name, element name, plus word cation. So for instance, aluminum would be aluminum cation. Don't I add a suffix? No. Don't I add a prefix? No. I just write the word aluminum and write the word cation, and that is it. Woohoo! Piece of cake. All right, magnesium. What is its formula? Mg2+. What is its name? The magnesium cation. Yahoo! I bet you guys can do this one. Go. Pause me and bring me back when you're ready. All right, it's a monatomic ion, potassium. Let's go to the periodic table. Where is potassium? Potassium is K right there. So that is a +1 charge. It will form as an ion, and so it's going to be K plus. And what do we call it? Potassium cation. Good, 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 good. Next, consider the monatomic ion formed from iron. What are its formula and name? Okay, let's go to the periodic table. Where's iron? Did you see IR anywhere? IR, IR. Oh, no, no, no. It's not IR. It is what? Fe. There we go. Fe. Now, is it a +1, +2, or +3? Well, Mr. Smith, you haven't told us because this is what? This is my D block and my F block, and there are special things about D and F. And what is special about D and F? These guys can form multiple cations. That means they can form more than one type. They can form +1, +2, or +2, +3, or +3, +4, +5, or +2, +3, +4. It all depends on the specific element. So let's write down some notes here. We have to write a caveat here that, oops, I have something special here, and we're going to call them elements with multiple cations. And so what are we going to do with these guys? Well, let's first identify which ones. We're talking about most, D block, F block, and other metals. Ooh, you guys remember what other metals are? Well, other metals were what? These were my P block metals. And so if we look at our periodic table, what are we talking about here? We're talking about anything in here, and these bad boys right through here. These guys all can have more than one cation. Good. Now, the bad news and good news for you is the bad news is there are some I want you to know. The good news is I don't want you to know them all. So what are the ones that I want you to know? First, iron is going to make +2 and +3 most commonly. Copper is +1, +2. Lead is +2, +4, and tin is +2 and +4. So I want you, for my class, to memorize these guys. Now, you have to remember, anytime I have an element in the D block, we have to assume that it forms multiple cations. However, there are some exceptions. Okay, and really, these guys we want to put over here. We have some D block which form only, well, I should say only, but most of the time, one cation. And so these are kind of exceptions to the D block. Silver is almost always +1. Zinc is almost always +2. Cadmium is almost always +2. If you look at those in the periodic table, they're aligned just like that. And so I want you to memorize that these guys do not have multiple cations. They only form one cation. And that will become important later. Good. Oh, I'm confused now. What's my question? Okay, I need to know the formula and the name for iron. Well, I really don't know. We said iron could form what? We said iron can form two types. So iron could be +2 or +3. All right, good. So let's answer it that way. Iron can form +2 or iron can form +3. And so we'd say what? Based on the way we had named things, we'd say this is the iron cation and this is the iron cation, right? Wait a minute. These things are different. That's a +2 and that's a +3. How can they have the same name? Well, they can't have the same name. So we have to somehow identify them as being different. And so what we do with these guys over here that have multiple cations, the way we name them is we say the metal name. So you put the element name. And then charge in parentheses. Parentheses. And then the name, and then the word, so, and then the word cation. So we look at this, right? That is 10. What's the charge? 4. So we're going to put it in parentheses as a Roman numeral. Charge in parentheses as Roman numeral. Okay, so what's the Roman numeral? There we go. So we'd call that 10-4 cation. This would be copper 1. Copper 1 cation. Good. So we go back to our question. What is this then? This would be iron 2 cation, and this would be iron 3 cation. And so that's how we tell them apart. Good, 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 good. Here we go. Consider the monatomic ion formed from lead. All right. You guys give this a try and bring me back when you're ready. Okay, lead. Lead we had in our list over here, right? Where's lead? Here is lead. Good. Lead is Pb2 plus and Pb4 plus, and you all will memorize that, correct? And so here's Pb2 plus, and here's Pb4 plus. Now, how do I tell them apart? I would say what? This is the lead. The name for this is lead what? 2 cation. And the name for this would be what? Lead 4 cation. All right. That's not so bad. Good. Here we go. Let's see, you guys give this one a try. Consider the monatomic ion formed from silver atom. What are its name and formula? Okay, bring me back when you're ready. Aha. Okay, this was a trick, right? Of course, we look at our periodic table and we find silver here, right? You say, D block, multiple cations, right? No, because I said in our notes, there are some D block that only have one cation, and among those is silver, and we have to memorize silver as +1, zinc is +2, and cadmium is +2. And so what do? We come down here, we say, okay, what's the formula? The formula is silver. There's only one of them, it's silver plus, and what's the name? Well, we're going to name it like any other regular cation, silver cation. Well, don't we put the charge in parentheses? No. Why not? Well, there's no ambiguity. There's always just silver plus. Since there's no ambiguity, there's no need to put a charge in parentheses. Everyone knows that silver cation is Ag+. Whereas if I just say iron ion, some people are thinking iron 2, some people are thinking iron 3. All right, great. And I think I want to quit right there. See you guys.